This is the 2015 FRQ number 5, which is a non-calculator question. And you'll notice that we have a curve, and this is actually a curve sketching question. So you're almost guaranteed to get one like this on the AP exam, and hopefully that's good for you because these ones we've spent a lot of time talking about. So I hope that you have an easier time answering these ones. It says this is a graph of f prime, so I think it's a good idea to notate that this is a graph of f prime, so that that's kind of in the back of your mind as you're reading these questions. It says the figure above shows the graph of f prime, the derivative of a twice differentiable function. Again, remember that twice differentiable, it just means that you're able to take the derivative of it twice. So it's just a fancy word to say that, yes, you can take the derivative twice. It says on the interval from -3 to 4, the graph of f prime has horizontal tangents at x equals -1, +1, and 3. So maybe let's just draw some horizontal tangents at -1, +1, and 3. And that way we don't forget about those later. It says the areas of the regions bounded by the x-axis and the graph of f prime on the intervals from -2 to 1 and from 1 to 4 are 9 and 12 respectively. So the area of this region is 9 and the area of this region is 12. Now, we won't be able to do anything with that yet because, again, that has to do with the integral, which we're going to talk about second semester. However, for right now, it's just a nice thing to kind of label them as such. So we can actually do quite a bit of this problem, unlike some of the other problems we've been working with. So let's look at part A. Part A says find all x coordinates at which f has a relative maximum. So remember, to find a relative maximum, we have some steps. If we're given a first derivative, remember that a relative maximum is we're looking for zeros of the first derivative, and we're looking for where it goes from positive to negative, because that means that the original function would have gone from increasing to decreasing. So if we look up here at this graph, I see 3 zeros. I have a 0 at -2, a 0 at 1, and a 0 at 4. And of these 3 zeros, only one of them has y values that change from positive to negative, and that is this one right here, meaning that that on the original function is a relative maximum. So it says find all x coordinates at which f is a relative maximum. Part A. X equals -2 is a relative maximum on the graph of f because and then here's where you can use that green paper that I gave you to justify your answers, but mine might not look exactly like that, but it probably has some of the same components. So it's a relative maximum because it is a 0 on f prime, and f prime of x changes sign from positive to negative. Which means, and I told you I'm an over-explainer, so this is me over-explaining this. But if f prime changes sign from positive to negative, it means that f changes from increasing to decreasing. Again, I'm an over-explainer. You probably could have gone away with leaving it after this comma. However, I like to make sure that my point is seen. That's worth 2 points on the AP exam, so you would get 2 points for that answer, which is pretty good. I mean, 2 points is a lot for that, and I think all of you guys could easily get that answer correct. Part B. Part B says, on what open intervals contained between -3 and 4 is the graph of f both concave up and decreasing. Sorry, concave down and decreasing. Give a reason for your answer. So, we're looking at both of these things. To figure out where the original function is concave down, if I'm looking at the first derivative, I'm looking for where the first derivative is decreasing. And to figure out where the original function is decreasing, I'm looking for where the first derivative is negative. So in other words, I'm looking for where this graph, which is the first derivative, is negative and decreasing. So let me get out a highlighter. Let's see if we can highlight this really quick. Negative and decreasing. So right here, oh, you can't see that. There we go. Negative and decreasing is from -2 to -1. And then again, it's negative and decreasing from 1 to 3. Here it's positive and decreasing. Here it's negative and increasing, as well as here it is negative and increasing. So if I want my original function to be concave down and decreasing, the first derivative needs to be decreasing and negative. So on what open intervals? These are the open intervals from -2 to -1, as well as 1 to 3. -2 to -1 and 1 to 3. And don't forget that it says that we have to give a reason for our answer. If you do not give a reason for your answer, you will not get full credit. So -2 to 1, -1, as well as 1 to 3 are intervals where f of x is concave down and decreasing because f prime of x is, and again, I'm sorry, I'm super nitpicky, but notice that my prime kind of blended into my f. Make sure that you can tell when you're writing prime versus writing just f. So f prime of x is negative and decreasing. Again, I could take more time and over-explain it like I did in part A, but I'll leave it there. I could interpret that f prime of x being negative means f of x is decreasing, and that f prime of x decreasing means that f of x is concave down, but I will save you from my over-explanation in this case. Alright, and then let's look at part C. Part C says, find all x coordinates of all points of inflection for the graph of f, give a reason for your answer. So remember that if we're looking at a graph of the first derivative, the original function will have points of inflection wherever the first derivative has a turning point. So I see 3 turning points, and that's why I had you guys look at these horizontal tangents. I have a turning point at -1, a turning point at 1, and a turning point at 3. And they have to actually change direction. So essentially it's a horizontal tangent that also changes direction. So it has to be a maximum or a minimum. So I'm going to write x equals -1, 1, and 3 are points of inflection. Again, we have to give a reason for our answer. And this question on the AP exam makes you give reasons because the answers are not that hard to find. It's the reason they want to make sure you actually know what you're doing. X equals -1, 1, and 3 are points of inflection on f because they are relative extrema on the graph of f prime of x. And again, I will save you from an over explanation. So that's 2 points. Alright, and then last but not least, part D says, given that f of 1 equals 3, write an expression for f of x that involves an integral. Just reading that alone makes me think, hey, I don't know how to do that yet. We're not in second semester, so we'll stop there. So we actually could get quite a few points on this one. We could get a total of 6 points just by knowing knowledge of first semester. And it's almost guaranteed, alright? Not guaranteed, but almost guaranteed that you're going to get one of these questions on the AP Calculus exam. They love to put curve sketching questions on there.